Okay, now lead and magnesium alloy again. Here is the URL. So let's find the composition of lead and magnesium first. So the composition of lead will be, because now the masses are given in terms of pound mass, so we can use pounds over here. We don't need to convert pounds into kilogram because composition is simply the ratio. So if you take the ratio of kilogram to kilogram or pound to pound, the ratio will be same. So lead is 37 pound. 37 pound divided by 37 plus 6.5. So we calculate it. So it is 85%. And therefore the composition of magnesium will be then 15%. And temperature, remember that it's 400%. So 400 degrees centigrade. So composition is given in terms of lead. Lead is 85%. 85% is here. %, lead is here. Temperature is 400 degrees centigrade. 400 degrees centigrade is here. So here, so this point is in this region. Liquid plus Mg2Pb, which is actually called magnesium plumbide. So two phases are present. So phases are liquid and Mg2Pb, so which is called magnesium plumbide. Magnesium plumbide. So actually this is magnesium plumbide is a compound, chemical compound. So the composition of liquid and the composition of Mg2Pb can be read from the phase diagram. So magnesium plumbide is here, this vertical line, so which is about 81%, and this line over here is this is the composition of liquid, 92.5%. So 81% and 92.5%. %, and 92.5%. So here we have to find the phases for this given alloy. 8.2 mole of nickel and 4.3 mole of copper at 1250 degrees centigrade. So we need to find the compositions. For these compositions we need to find the weights first, and the weight we can find in grams by these moles. So we know that atomic weight of nickel is 58.69 gram per mole, and the atomic weight of copper is 63.55 gram per mole. So the mass of nickel we can find by multiplying 8 with 58.69, so which will be equal to which will be equal to 481.23. So this will be 8.2, and the mass of copper will be equal to 4.3 into 63.55. So it will be equal to 273.3. So these are the grams, these are the grams. So therefore composition of nickel will be equal to 481.3 divided by 481.3 plus 273.3, which is equal to 63.8%. So take it 64%. Okay. So therefore the concentration of copper will be 100 minus 64 equal to 36%. So now we see the copper nickel diagram at 1200 degrees 50 degrees centigrade with concentration of nickel at 64%. Concentration of nickel is 64% here, 64% at 1250 degrees centigrade. 1250 degree centigrade is there. So it's obvious that we are in the alpha region. So phase is alpha, and then concentration of alpha is obviously 100%, with individual percentages as 64 and 36% for nickel and copper respectively. Okay, need to find the phases for 4.5 mole tin and 0.5 mole lead at 200 degrees centigrade. So first of all, find the weight of mole. So mass of tin is equal to 4.5 times the atomic weight of tin. So atomic weight of tin is 118.71, and then mass of lead equal to 0.5 mole of lead multiplied by the atomic weight of lead, which is 207.2. So this will be equal to 534.2 gram, and this will be equal to 93.2 gram, 2 gram. And their concentration of tin will be 534.2 divided by 534.2 plus 93.2. So it will be equal to 85% or 0.85 or 85%. So concentration of lead will be equal to then 100 minus 85, it equal to 15%. So let's look at the lead tin chart at 200 degrees centigrade. So this is the lead tin chart. Tin is 85%. Tin is 85%. 85% here. And temperature is 200 degrees centigrade. 200 degrees centigrade. Here. Yes. So we are in liquid and beta phases. Okay. Beta plus liquid. Okay. So two phases are present. Liquid and beta. So composition of beta and the is equal to, and the composition of liquid is equal to. So we can see it from here. Here, yes, somewhere here is the composition of liquid. So around here, which is 74%, and for the beta is here, somewhere here, which is about 98%. So liquid is 74%, beta is 98%. So 74% and 98%.